Hi, I'm Ananya, and this is our medicine reminder alarm. We use the photoresistor, right there, to determine whether it is day or night by the sensor value. We have two frequencies coming from the piezo depending on the input of the photoresistor. I will be demonstrating how it works. So right now, the photoresistor is sensing that it is nighttime, and it's displaying one tone, and the piezo is emitting one frequency. So now the photoresistor is sensing that it's daytime. I just shone a flashlight on it, and it's emitting a different tone from the piezo, and the LCD is displaying a different message. So if we just see that again. As of right now, the alarm is always on, so if we were to refine this, we could set the times of day when it would exactly go off.
Okay, my name is Ian, and I'm about to explain the code. So we based the code off of two projects we did, namely the crystal ball project and the light theremin project. So up here, we included all of the necessary components of the liquid crystal library, and it's hooked up in the same way as the project. Down here, we set up the photoresistor. We hooked it up to an analog pin so that the Arduino can read its sensor value, and we designated a threshold. In this case, our threshold is 512, so it's about halfway through. It's about halfway from in between the range of the possible inputs that it can have. So from 0 to 1023. So this is how it works in the code. So if we detect that the sensor value of the photoresistor is greater than the threshold, then we'll tell the LCD to print one thing, and we'll also write a special character to it. But there was a problem. So the LCD print command will keep printing something to the LCD. So if we keep that in a loop, then it would keep printing that message over and over again. So we only wanted to make the message print once, and we wanted to make it print basically when the sensor value crossed the threshold. So in the setup, we made it display one message. So this is the initial message based off of the initial light reading in the room. And then in the loop method, we made it so that we defined a value called previous value. And if the previous value is the sensor value, but at the end of the loop method. So if the previous value is less than the threshold, but the new sensor value is above the threshold, then that means that the sensor value has crossed the threshold, and so it'll call the print command. And after it does this once, then the previous value will now be also over the threshold, so now it won't keep printing. So by using this previous value variable, we made it so that it only calls lcd.print when the sensor value crosses the threshold, and this keeps the screen from getting cluttered. And of course, we use the LCD clear in order to make sure the screen is cleared before we print a new message. And in terms of including another LCD method, for this we use the lcd.createCar method. So basically, it lets us define a special glyph of our own, which is written as a byte variable. And we made it so that after each of the messages, it'll write that glyph. So in this case, it's a smile. And yeah, that's written after every message. So that is the code.
So, hello, my name is Greg Lova, and for this project, we based it off of the light theremin and crystal ball projects. We basically just combined the ideas from those two projects into one and did it that way. And it's hooked up in the same way, but the potentiometer is replaced by a regular resistor. And that means that we cannot change the contrast of the screen, so it'll just be constant. We attached the resistor to the piezo as well, so that would not interfere with the LCD. Our output pins are the same as in the crystal ball project as well. The three components are hooked up differently. There are two separate circuits, one with the piezo and one with the LCD screen. And the piezo is on its own closed loop and is connected to the digital pin. Meanwhile, the photoresistor is connected to the analog pin. The photoresistor is the input, and the LCD and piezo, they act as the outputs. And we also use the LCD Arduino library in order to print the messages on the screen.